Welcome to part 7 of our solution. So far we had a very picky princess that wanted to maximize the probability of getting the prince with quality 100. And we learned that this comes at a cost because the probability of selecting no princess at all is also very high. So whenever Prince Charming is already in the test group, no prince will be selected later on. And let's again visualize this finding, and we make two plots in our graph. And the first plot is actually repetition. We already plotted it, and shows the relationship between the size of the test group on the x-axis and the probability of getting Prince Charming. And therefore again we are creating here a results list with 100 results. So for all test group sizes here from 1 till 100. And on our plot we plotted here. So on the x-axis the size of the test group from 1 till 100. And on the y-axis our results list, and we label the graph here probability of getting Prince Charming. And we are producing a second graph that shows the relationship between the size of the test group and the probability of getting no prince at all. And actually we do not have to simulate the second graph because it's quite obvious. So if we have a test group size of 1, the probability of having Prince Charming in the test group is 1 divided by 100. And therefore the probability of getting no prince or selecting no princess at all is 1 divided by 100. And if we have a test group size of, let's say, 23, the probability of Prince Charming being in the test group is 23 divided by 100, and so on. So actually here we have a straight line, and we plot here the straight line with just two data points here. So we have data point with on the x-axis 1 and the probability 1%, and with the size of the test group 100 we have the probability of 100%. And we label this graph probability of getting no prince at all. So let's run here our cells. So here the blue graph shows the probability of getting Prince Charming depending on the size of the test group, and the graph we already know here. And the green graph shows actually the probability of getting no prince at all depending on the size of the test group. And you can see here that it's kind of a trade-off, because if the size of the test group is very small, the probability of getting Prince Charming is also very small, but the risk of getting no prince at all is also very small. And if we increase the size of the test group, then until a size of 37, 38, the probability of getting Prince Charming increases, but also the probability of getting no prince increases. And from this point on, both the metrics actually are getting worse. So the probability of getting Prince Charming decreases, and the probability of getting no prince increases. Alright, so now let's go on, and we assume that we advise another princess in another kingdom, and this time our princess is more risk averse. So she does not want to end up with no prince at all here, so she's very afraid of the green line here. And instead of maximizing the probability of selecting Prince Charming, now our new princess wants to maximize the expected quality of our selected prince. So actually the average quality over all simulations. And so far our princess function only calculates and returns actually the probability of getting Prince Charming, and therefore in the first step we should introduce more metrics as a possible return of our function. And therefore in our function header we introduce the parameter metric, where we can define which metric the function should return. And there are actually three possibilities. So first of all, we can select that our function returns the results list with the results of all simulations. or the probability to get the Prince Charming, so this is nothing new, or the average over all princes. And we set results as the default argument for our parameter metric. So now here we have to fill results as default argument. And in our princess function, we should also calculate here the average over all results. So we take the sum over all elements in our results list divided by the amount of simulations. And then depending which argument we passed here for our parameter metric, our function should return either results, probability best, or average. And therefore we have to introduce an if-elif statement here. So if metric is equal to results, we have to return our results list. And else if our metric is probability best, then our function should return probability best. And else if our metric is average, then our function should return actually the average. Alright, so now let's run the cell and define our function. And we should check if our new function works, and we should pass all three metrics to our function. And therefore we are setting the size of the test group to 37. So this is around about the best strategy for our former princess, which wanted to maximize the probability of getting Prince Charming. So first of all, let's pass here the probabilities. So we already know this here. And let's run here. So with a roundabout optimal test group size of 37, we have roundabout a probability of 40% to select Prince Charming. And let's also calculate the average over all results. So here we get roundabout 65 as an average quality of the princes. And we can also return the results lists with all 1000 simulations. So let's do this here. And here we can see we have here our results lists with 1000 simulations. So with the optimal strategy to maximize the probability of getting Prince Charming, we get an average quality of 65, and I guess that there's a lot of room for improvement actually for our new princess here. And what we want to do now is actually want to find the optimal size of the test group in order to maximize our metric average. And therefore again we have to iterate over all possible test group sizes, so from 1 till 100 if we have 100 applicants. And for each simulation or iteration, we call our princess function with the metric average and calculate the average over all simulations. And then for each simulation, we store the result in a list, and then we want to visualize the outcomes. So actually this is nothing new. So we call here our princess function for each test group size from 1 till 100. With the 1000 simulations, and this time we set the metric to average, and we append each result to our empty list average 1000 sims. So let's do this here. Then again here we import matplotlib, and then we make a graph here with the fixed size 12.6. And then we plot our graph with the size of the test group on the x-axis, so from 1 till 100, and on the y-axis our results here in our average list. Then we call our x-label size of test group and our y-label average quality of the selected princes. And we have the title Prince Selection with 100 applicants and 1000 simulations, and we set the font size to 15. So let's see what we get here. And we see here that we can actually maximize the average or expected quality of our princes when we set the size of the test group to only 5 princes here roundabout. And by doing so, we can manage to increase the expected quality from approximately 65 when the test group size is 37 to above 80 here. So if our test group size is only here 5 princes, then we can expect to get a prince with the average quality of over 80. And now with the test group size of 5, we can also make a histogram. So here we call our princess function with only 5 princes in the test group. And we want that our function returns a list with the result of all simulations. So we pass here results. And we save our results lists here in the variable results. And then we make a histogram with fixed size 12.6, and we pass to PLT_hist our results list which we created here. And we want to have 101 bins, and we call the X-label quality of selected prints, 100 is best, and the Y-label number of occurrences or frequency. And we have a title print selection with 100 applicants, a test group size of 5 and 1000 simulations. So let's see what we get here. Yeah, and we can see here that our histogram looks quite different compared to the histogram with the test group size of 50 or 37. So actually we have less frequency here in the extreme outcomes. So the probability of getting no prints is only here 4 or 5% roundabout. And also the probability of getting Prince Charming here is only 14 or 15%. And this is because we have more results and more frequency here in the middle. And by doing so, we could increase the average quality of the princes. And we can also compare this again to the histogram when we have a test group size of 37. So let's do this here. We can set here size test group to 37. And now let's see how our histogram changes. So this is actually a tremendous difference here. So here we have a probability of getting no prince at all of about 35%, and we have a probability of getting Prince Charming of about 40%. And actually we have no results here in the middle. Alright, so now we are finished with this session, and in the next and the last session of our solution with the Python standard library, we completely change our strategy. So hope to see you there. Bye.